Hello everyone, I am Professor Mane, working as an Assistant Professor in Keystone School of Engineering, Pune. Today, in this video lecture, we will see the overview of Engineering Mathematics subject. So, first of all, the course outline. This is the fundamental and essential subject in all streams of engineering. At the end of this video lecture, we will get the brief idea about the topics and the immense contribution of this subject in the real world. We will start with the course objective. The total credits is 4 plus 1. The total marks are 125, which is distributed in INSEM, ENDSEM and the term work. And the prerequisite, that is the fundamentals requires, are derivative and the integrations, as well as the coordinate geometry. These are the contents, course contents listed here. If you observe the first two units, first is first order ordinary differential equation and the second is application of differential equation. The two units are the syllabus for the INSEM examination, which will be conducted by the university for the 30 marks. And the unit 3, 4, 5 and 6 are the syllabus for ENDSEM examination. If you observe first two units, that is dependent on each other. First, we have to learn the first order differential equation and the second is the applications. See, these are the course objective and the course outcomes. There are total 6 units, but we combine the first and second unit for the CO1 and rest of for CO2, CO3, CO4 and CO5. What we have learned here? We have learned here the advanced techniques for the mathematics and we are enhancing the thinking power. Now, the first unit is first order ordinary differential equation. This unit is very important because of this immense contribution in the real world. First of all, what is meant by differential equation? See, the subcontents are listed here. You have to learn here order, degree, formation of differential equation from solution, and in second part you have to find solution by using differential equations. Now there are various methods, that is the variable separable method, homogeneous differential equation, exact differential equation as well as linear differential equations. So many times the question arises, where the differential equation exists in real life? Yes, it exists. How? So, first of all, we will see what is the definition of differential equation. Differential equation is that equation which contains dependent variable, independent variable and the differential coefficient. In simple language, we can tell that equation which contains the derivative. See, this is the one simple differential equation. In real life, the differential equations exist. We are using the physics here. What is meant by differential equation? This is nothing but the study of change. We are modeling a differential equation. We are modeling the physical changes with the differential equation. It is just like an app, right? So, what is Newton's second law of motion? You know from physics, Newton's second law of motion. Force is equal to mass into acceleration. Suppose apple falls, then how many forces acting on that apple? You know, the gravitational force is acting on the apple as well as there is an air resistance. So there are two forces acting on this apple. So how many forces? Force is equal to mg, that is the gravitational force, and the air resistance. Why this negative signs? Because of the resistance. So total forces is nothing but the mass into acceleration. And what is the acceleration? That is change of velocity with respect to time. So this is the mathematical model of the falling of this apple. Okay. Second example is of the spring mesh. If I pull the mesh, if I apply the force and pull the mesh, what will happen? It starts oscillating. So this physical change we can model by using differential equation. So force is equal to mass into acceleration. Next, these are the real life examples of ordinary differential equation. Suppose I stand standing on the building and thrown a stone, what will happen? The stone, it will attack the ground. Okay, so position of this stone, or you can say the distance traveled by the stone from the initial point, is modeled by using the differential equation, and that is nothing but y double dash is equal to constant. That is the gravitational constant. So this is the differential equation. Why? Because the derivative is exists there, right? This is the second example. That is a vessel, and there is a tap at the bottom. So fluid of that motion of that we can calculate by using the differential equation. Suppose next example is of parachute. This is the complex structure. This is not easy about this falling stone, right? The air is acting on the parachute. So what parachute does? The parachute is restricted the falling object to fall very quickly. So we can model the equation of parachute by using the differential equation. So this is the real life examples of differential equation. Now we are solving the differential equation. That means what we are doing? We are finding the distance, we are finding the relation between the dependent variable and independent variable. So in real life, how we can relate it? See, in this we are relating the situation by using differential equation, and when we are finding the solution, again we are relating the situation. So suppose I have one ball and I throw that ball. What will happen? How the distance covered? See, this is the ball, positions of the ball at various times. So what is this distance? If you observe the path is like parabolic. So how we find the differential equation? This is again the acceleration is equal to constant. D square y by dx square is equal to acceleration constant is g. This is the differential equation. Why? Because it contains derivative. It is of second order. Suppose if I have to solve this differential equation, how we solve? We are integrating on both sides. See, if I integrate d square y by dx square, we get dy by dx. Acceleration constant, keep g as it is, and when we are integrating with respect to x, the integration of 1 is x, plus we have to take the arbitrary constant, that is a. Okay, if I again integrate, dy by dx is now become y, g as it is, integration of x is x square by 2, this a as it is, integration of 1 is x, and again the arbitrary constant is b. So if you observe this, what is this? This is the distance travelled by that ball, and you are getting y is equal to x square, such type of equation if you are ignoring the arbitrary constant. So y is equal to x square is nothing but the parabola, right? Now this is all about unit first. Now second unit is application of differential equation. So these are the contents of unit second. There are various applications you have to learn in this unit. First application is Newton's law of cooling. Second is rectilinear motion. Then third is orthogonal trajectory. Orthogonal means perpendicular, trajectory means curves. So you have to learn here perpendicular curves. Next is rate of decay. In that rate of decay, there is a rate of growth also you have to study. And the last but not least, that is the heat flow and electrical circuit. These are the applications of differential equations you have to study in this unit. This unit is very much easy, and students can score in this unit because there is a particular method to solve the differential equation in every applications. So before we start the Newton's law of cooling, we will see one interesting clip.
I'm finally finished cleaning after a whole day of work, and everything's ready for the office party. But wait a second, what's that? Someone's been murdered!
Someone has been killed. You have been selected among the brightest differential equation students to help us crack this case.
So can you use differential equations in real life? Yes, you can use. See, in Newton's law of cooling, what you have to study. It is the Newton's law of cooling is finding the killer. So if you observe this, see who is the killer? Suspect A, suspect B or suspect C or that sweeper. So what actually you have to find? See, when police comes, what he will take the statements from the suspect A, B, C and the sweeper, and how they are finding the killer. First of all, what you have to find the time of that day, and at that time those people or those person will be with that victim, that will be the killer, right? So how they can find the time of death? Okay, so there are several observations. The body temperature they have taken, see, at 6 p.m. the body temperature is 30 degrees centigrade, and after the 1 hour the body temperature will be 28. It will be reduced, right? So, and the room temperature, that is the constant. We are ignoring the another contents in that room, and that the room temperature is the constant term. So what is the Newton's law of cooling? This is the Newton's law of cooling, that is dt by dt. That is the rate of change of the body with respect to temperature of the body with respect to time is proportional to the difference between the temperature of the body and the surrounding medium. So this Newton's law of cooling will helps the finding the time of death. So how? See, if you observe this, at time 6 p.m. you are getting the temperature 30, and time 7 p.m. you are getting the temperature 28. So we separate this variable. See, we are using the variable separable form. Which variables are there? This is capital T and this TS. See, these variables are separating, and then we find is integration. Integration of t minus 24 is no go, t minus 24, and we are substituting the upper limit and lower limit. Minus k is the constant, and the integration of dt is t, upper limit and lower limit we are substituting, and we are finding the value of k. K is nothing but a proportionality constant. Now we have to find the temperature. What is the normal temperature of the body? That temperature is 37, we know, right? So normal temperature of body is 37. So when that victim is alive, the temperature of body is 37 approximately. So at 37 you have to find the time. And what is the initial condition? We are using this initial condition, right? So what is the unknown now? You have to find time. That means the t is unknown. By solving this differential equation, you are getting the time is equal to 1.9070. That is approximate about 2 hours. So we can conclude the time of death is around 4 p.m. right? So Newton's law of cooling is using in we can say in medical field also. In medical field, we are using the Newton's law of cooling, that is the application of differential equation. Now, by using Newton's law of cooling also, we can find the time when the ice cream will completely melt. In electrical circuit, we can find current in the circuit by using this differential equation. Again, the question is it differential equation? Yes, it is differential equation. Why? Because it contains di by dt. That is the derivative of I with respect to time. So if you solve this differential equation by using the linear differential equation, you can find a current in the circuit. Next application is decay of radioactive materials or rate of growth of population. This law, again we have to study. What is this law? Disintegration, that is dN by dt. Disintegration at any instant is proportional to the amount of material present. This is the rate of decay law. Why there is a negative sign? Because it is decreasing, disintegration. Like radioactive materials, we can say cobalt, uranium, radium. It is continuously decreasing, right? So this application is used in the cancer treatment also to see the growth or decay. Again, the growth of population, here we are taking the positive sign because the population is constantly increasing. Even we can say in India the population is constantly increasing. So we are taking the positive sign, dp by dt is equal to kp here. So you have to use this differential equation and you can solve this to find the solution. Now, Unit 3 is the integral calculus. So why I have to learn this integral calculus? Before that, we see the subcontents are, we have to here learn the 4 subtopics, that is the reduction formula, error function, beta and gamma function, and the differentiation under integral sign. This 4 topics you have to study in this integral calculus. So, what is the reduction formula? Why you have to study this reduction formula? What you know about the integration of sine theta is minus cos theta, right? But someone asked, find the integration of sine raised to 6 theta, or sine raised to 8 theta, or tan raised to 10 theta. Can I find? No. So for that, we have to use this reduction formula. What reduction formula does? This is the reducing the power. Sine raised to 10 is reduced into the up to sine or sine square, right? So these are the reduction formula. We are reducing the power and then we calculate. See here, IN. IN is equal to integration 0 to pi by 2 sine raised to n theta. If we have to see here, right hand side, IN minus 2. That means the power is decreasing. What is IN minus 2? That is nothing but sine raised to n minus 2. Okay, so we are decreasing the power and we can find the integration of any trigonometric term of higher power, integration of sine raised to 100 theta if you have to find. So I can use first reduction formula. I reduce the power by using this standard result. You can derive this result, okay, and there is not restriction about the limits also. For any limits you can derive the formula. So that's why you have to study reduction formula. Gamma function, you know what is the 3 factorial. 3 factorial is 3 multiplied by 2 multiplied by 1, that is 6, right? But if someone asks, find a 5 by 2 factorial or 7 by 2 factorial, how we can find, right? So for that, gamma function will help. Again, the beta function, there is a relation between beta and gamma function. Beta mn is nothing but gamma n upon gamma m plus n. Then we can find the relation between beta and gamma function. Then the next topic, that is the last topic, DUIS. The name itself told DUIS, differentiation under integral sign. If you observe this example, see, this is the integration and you have to integrate with respect to x. So this may be difficult because there is x at numerator as well as denominator. So I can't find this integration very easily, right? So I will use the differentiation under integral sign concept. What you are doing here, we are taking the differentiation with respect to parameter. There is a parameter, there are 2 parameters a and b. So here, by using the parameter a and b, you can differentiate it, and again we have to take the integration with respect to parameter, right? So this is the DUIS. Unit 4, that is the curve tracing. Curve tracing unit 4 and unit 5, the students like this unit generally because there is a little use of derivative and integration. So what you learned so far, if I have to draw one curve or I have to draw the graph, so what will I do? I will compute the points. So many points I will compute and I will connect that point. So we will get the graph or curve, right? But in curve tracing, you will get directly the idea without computing the points. We have some theory, we have to use that theory to compute. Without computing the points, we can have clear idea about the curve tracing. So in this unit, you have to learn Cartesian curve, polar curves and parametric curves. Cartesian curve, there is a combination of x and y. This is the Cartesian curve. See, this curve is very complex, right? So by using Cartesian curves, there we can describe the part in terms of horizontal and vertical distance. In polar curve there is a one fixed point. That point is called pole, and from that fixed point, if you draw one straight line, any straight line, any direction, from in any direction, then it forms a radius vector. Now the parametric curves, we are taking the help of another variable to represent x and y. See, x and y they are representing, we are taking the help of theta, that is the another variable. So curve tracing, you will get full marks here for because there is no derivative and integration. In unit 5 also, unit 5 is nothing but the solid geometry. Here you have to learn sphere, right circular cylinder and right circular cone. Right, there is a fixed method, there is a fixed particular method to solve the equations, or you can say the finding the equation of sphere. So there are total 4 forms to find the equation of sphere: central radius form, intersect form, diameter form. See, you can see the sphere here. What is meant by sphere? That is the locus of the points which moves in a space such that the distance from the fixed point is called the radius, and that fixed point is called the center. Okay, so this is the sphere. See, this is the cylinder, right circular cylinder. This is the, again, it is also rotating. It is rotating along the straight line and intersecting with a fixed circle. Right, so the right circular cylinder. If you observe this right circular cone, the real life example of right circular cone is ice cream cone. Real life example of right circular cylinder, we can say this is the battery cell. Right, so again the cone, this is again the rotating along a straight line through a fixed point. That fixed point is called the vertex, and there is a constant angle with the fixed straight line. That fixed straight line is called the generator. Now, Unit 6 is multiple integrals and their applications. This is a vast topic because there is a double integral, triple integral. Again, there is applications, that is the moment of inertia, area, volume, center of gravity. So, why to study multiple integrals? See, we can find the area of circle, that is pi r square, or area of square. Area of square, see, there is a defined parameter in the square. What is that parameter? That the sides of all sides are same, right? So there is a fixed parameter. We can easily find area of circle, area of square, or a volume of sphere. But when the question arises, if I have to find the area of this curve or a volume of this curve, I can't find because I don't know the name of this curve, right? So what will I do? I will split this area. I will split this curve into the small parts, and then I will find the area of that particular part, and I will connect all the areas. And that's why, see, integration is nothing but the summation. See, there is a sign of integration that looks like the S, the letter S. Why? Because it is nothing but the summation. We are calculating the sum of all the areas. So for getting the double integration, triple integration, we can find the area or volume. Then again you have to learn the center of gravity, moment of inertia. This is a very vast topic. This is all about the unit 1 to unit 6. Now what is the question paper pattern? See, the question paper pattern is fixed. Each question carries 5 marks. There is an equal distribution. Unit 3, this is the end same examination for question paper pattern. See, unit 3, there is a OR, again beta function, reduction, DUIS. See, these are the compulsory topics. That means you can't skip any topic. Again, there is a particular question of Cartesian, polar, parametric. The question is fixed. Equal distribution is there for the every units. And when you have to think about for quasing, then you can see the unit 4, that is the tracing of curve, and unit 5, that is the solid geometry. You can easily get the marks, right? If you are weak in the derivative and interesting. Otherwise, these 2 units are very interesting. Now, this is the overview of the topics. Now, we will see the applications part. See, these are some industrial applications. First is arteries. We can derive a mathematical model for the blood flowing through the arteries, or you can say blood flowing through the kidneys or various organs of the body. We can find the rate of flow of that blood by deriving the mathematical model, and that is the differential equation. Second is very recent, that to analyze the COVID pandemic, we are using the differential equation that time. We are collecting the data, and by observing the data, we are finding some observation. We are collecting some observations in SR-ER models they are using that time there. S is susceptible, E is exposed. Susceptible means those people who are at a risk of getting infection. Then I is infected, and R is the removed, that is completely recovered from the disease or they are died. So these are the SIER model that will be this is the very famous model in analyze the COVID pandemic. This is again the differential equation. See, in air conditioner, in house, in offices, we are using air conditioner, AC everywhere, right? So it is controlled by the remote. So what that remote, see, this consumes the electricity. It reduces the consumption of the electricity because it is controlled by the, see, what is the main fundamental in the component in that AC? That is the compressor. You have to observe the temperature of the compressor. So by using the room temperature or velocity of the air in that room, we can control this various parameter by using that remote control. It reduces the consumption of electricity. Then in forensic science, earlier we have seen the example of Newton's law of cooling. That is nothing but the forensic science we are using. In rocket science also we are using differential equation to see the motion of the rocket. See, these are the another applications, that is the DC motor. What DC motor does, it reduces the speed of the process, right? In a drilling machine or in fan, the DC motor is used. In guitar and piano, why the guitar sounds and piano sounds are different? Because it relates with the sound variation with respect to time. Then scanner, this is the application, see, guitar and piano, this is again the application of this all the differential equation, and the scanner is the application of coordinate geometry. What scanner does? It scans the documents and we will get the hard copy. But what scanner does? See, this is the image. So what scanner does? This point out or observe the distance. It is that image is distributed in various points and it observes the distance. It memorize that distance or record that distance and also the color, and you will get a hard copy. This is the application of coordinate geometry. Same application is digital camera. The same procedure is in digital camera. Packaged food, that is the application of Newton's law of cooling. Again, see, if I have to find the materials required to construct the dome, if I have to find the materials required to construct the curve-shaped bridges, what will you do? This is the application of again the multiple integral, that is the unit 6. The materials required for dome we can find by using the double integrations or triple integration, you can see. Now some jobs, if you are interested in maths, if you are very much curious about the maths, you can go to this field after the completion of engineering. The statistical data analysis, then banking. See, your bank statement is also the application of differential equation. How? Because the interest rate is varying in your bank statements, because that depends upon the various factors, that is your fluctuating balance, that also affects on the interest rate, right? So in banking sector, you can go in share market, natural science. This is also highest paid job. Then again AI, robotics, you can apply. So this is all about the overview of the subject. See, the father of mathematics. That proves that mathematics reveals its secrets only to those who approaches it with pure love, with its own beauty. So hope this video will be useful for you. Thank you.